A cliff above the Pacific at Point Loma, San Diego, November 1959. A machine about a meter across stands on the scrub, and a few men crouch behind a barricade with a camera running. Charges of high explosive drop out of the bottom of it, one at a time, and go off underneath. The machine climbs in kicks. Not a smooth burn, a staircase of shocks, each one slamming the plate under it upward. Then it runs out of charges, and a parachute opens, and it settles back down onto the dirt. The engineers called it the hot rod. It flew for 20 seconds or so, and it settled an argument that had been running for years. A vehicle can be pushed by explosions set off behind it, over and over, and still fly straight. The explosives were ordinary. That was the only part of the design that was. Welcome to Sketches of Never, where we visit the world that we very nearly built. The hot rod was a scale model of a ship called Orion, and the full-size version was going to do the same trick with atomic bombs. The idea is easier to defend than it sounds. A chemical rocket is a spectacularly weak machine. You spend an enormous building full of fuel to put a bus in orbit, and you do it by throwing hot gas out of a nozzle at a few kilometers a second. That ceiling is what the bonds in the molecules will pay you, and no amount of cleverness raises it. A nuclear explosion is not a slightly better version of that. It is roughly 1,000,000 times more energy for the same mass of material. And in 1957, the United States had a great many of them and a production line running. The question nobody serious had asked out loud was whether you could stand behind one on purpose. Stanisław Ulam asked it. He had helped design the hydrogen bomb, and in 1946, he began wondering whether the same physics could push something instead of flattening it. He and Cornelius Everett put it on paper properly in 1955 in a classified study, and the answer they got was that the numbers worked. In July of 1958, the American research agency ARPA agreed to fund a study at $1 million a year at General Atomics in San Diego, and the thing acquired a name and a director. The director was Ted Taylor. He was a bomb designer, and by most accounts, the best of his generation at making fission weapons small. He had built the smallest one anyone had, and the largest pure fission one too. He was also, by every account, deeply uneasy about what he was good at. Orion was the one place that skill pointed somewhere other than at a city. The physicist he wanted was Freeman Dyson at the Institute for Advanced Study in Princeton, who took a leave of absence from the most comfortable job in theoretical physics to go and work on a spaceship. He later said he had never been happier. The ship was 4,000 tons, destroyer displacement, not spacecraft displacement, with a thick steel plate across its base and a stack of small nuclear charges inside it. In flight, the ship drops a charge through a hole in the plate. It detonates a short distance below. The plasma hits the plate takes the hammer blow, and a bank of enormous shock absorbers turns it into a push the crew can survive. Then it does it again a second later, and again, about 800 times on the way up, each charge about 1/7 of a kiloton. The obvious objection is that the plate melts. That had already been tested, though not for Orion. At a Pacific test in the mid-50s, someone had hung 2 graphite-coated steel spheres about 10 meters from the device, well inside the fireball. Afterwards, they were found intact, a skin of graphite gone, and the steel underneath fine. A surface can pass through the inside of a nuclear explosion and come out the other side. The pusher plate would lose a little of itself every pulse and hold. The shock absorbers were the part that made it a vehicle rather than a bomb. 2 stages of them, tuned so that the individual blows blur into steady pressure, holding the crew at 2 to 4 times their own weight. Heavy going, and nothing a person could not sit through. You would ride the whole climb in a chair. And the payload numbers are where a reasonable person starts to feel the pull. The reference ship would have put 1,600 tons into low Earth orbit. For comparison, the Saturn V, which still holds the record for the largest payload anybody has actually delivered to orbit, managed about 130. Orion was not an improvement on the space program we got. It was a different century of it, available immediately, out of hardware that already existed. Weight on this ship had stopped being the enemy. Every other space vehicle ever designed is a negotiation over grams. Orion had margin to burn, and the engineers kept failing to believe it. So Ted Taylor put a barber's chair in the design, a real one, cast iron and leather. Half a joke, half a teaching aid, and a way of forcing everyone in the room to understand what kind of machine they were drawing. One problem they had expected to be exotic turned out to be a plumbing problem. 800 identical units, fed from a magazine, released on an exact schedule, 1 per second, without jamming. Nothing in aerospace had solved that. Something else had, though, so the team went and talked to Coca-Cola, whose vending machines had been reliably dropping identical objects out of a rack for decades. Their motto, and Dyson was still quoting it 40 years later, was Mars by 1965, Saturn by 1970. They were not being whimsical. The trajectories were worked out. With a pass through a planet's atmosphere to shed speed on the way in, a round trip to the moons of Jupiter or Saturn came out at around 40 kilometers a second of total velocity change, and Orion could pay that. A 4 or 5 year voyage looked possible. The picture Dyson had of it was not a race. His explorers were like Darwin, taking a leisurely tour around South America in the good ship Beagle, and not like Amundsen running for the South Pole. To work out where to aim, Dyson made himself a table of the outer moons. 9 of them, 10 numbers each, in his own handwriting. Size, gravity, density, what you might be able to refuel with when you got there. The one he kept coming back to was Enceladus. The density he had for it was 0.618, light enough that it almost had to be ice and hydrocarbons, which is what you would want, both for refueling a ship and for finding something alive. That number was wrong. Enceladus is around 2.5 times denser than that, and in 1958, almost nothing about the outer moons was known well enough to be worth trusting. He picked the right moon anyway, for a reason that turned out to be sound and evidence that turned out to be junk. 40 years on, his son put that same sheet of paper back in front of him. He read it for a while and said, "Enceladus still looks good." Then Cassini flew through plumes of water erupting from its south pole. None of this was ever disproved. That is the part I keep turning over. There is no experiment in this story that came back wrong. No moment where somebody stood up with a result that killed it. What happened instead is that Freeman Dyson sat down and worked out the fallout. Every launch would put radioactive material into the atmosphere, and it would spread, and some of it would end up in people. The arithmetic gives you a number of statistical deaths from cancer for each launch, and his own published figure was somewhere between 1/10 of a person and 1 person. Sit with the phrase, 1/10 of a person, for a moment. Nobody identifiable dies. The number is real anyway. Dyson concluded that the price was too high. He was the project's own advocate, and the report went into a classified file where none of Orion's critics could read it. So this was not a public act. It was an honest one. The arithmetic changed the mind of the man doing it, which is the hardest mind to change. and it is not what killed Orion. What killed Orion was a treaty. In 1963, the United States, the Soviet Union, and Britain signed the Partial Test Ban, which prohibited nuclear detonations in the atmosphere and in space. Which is to say, it prohibited every flight Orion would ever make. American officials pushed for an exception for peaceful propulsion. It never made it into the text. And it is not hard to see why. A fleet of ships that can carry 800 nuclear devices into orbit is difficult to distinguish from a distance from a fleet of ships carrying 800 nuclear weapons into orbit. That distinction was the second problem. The Air Force was willing to keep funding Orion, but wanted a mission attached. And the mission they had in mind was a deep space battleship. NASA had decided in 1959 that its program would be chemical for the foreseeable future. Everybody admired it. Nobody would own it. The last of the money went in the winter of 1964 and 1965. The whole project had cost about $11 million over 7 years, which even then was not a great deal of money for a spaceship. Dyson wrote its obituary in the journal Science that July, under the title, "Death of a Project." And years afterwards, he described it as the first time in modern history that a major expansion of human technology had been suppressed for political reasons. His objection was narrower than it sounds, and worth getting right. What he could not accept was launching it from the ground, up through the air the rest of us breathe. He never stopped drawing the ships. 3 years after he wrote the obituary, he published a paper on using the same idea to reach other stars. And decades on, asked directly whether the dreams of 1958 were dead, he declined to say yes. Both of those are him. He never resolved them for us, and I do not think he could. Ted Taylor went to Washington. From 1964, he was deputy director of the agency that minded the American nuclear stockpile. And it was there, reading what crossed his desk, that he worked out how easily the material could be walked out of a building. He resigned in 1966 and spent the rest of his life on the other side of his own expertise, working on safeguards and warning anybody who would listen. John McPhee followed him around for a year and turned it into a book in 1974. The man who wanted to use bombs to get to Saturn spent his last decades trying to keep them out of the wrong hands. Every other story I tell you on this channel ends with somebody being wrong. The ether was not there. The canals were not there. This one is different, and it has taken me a while to work out how to say it. Orion was never shown to be wrong, which is not the same as saying it would have worked. The question that mattered most, whether that plate could take 800 real detonations, could only have been settled by setting off a nuclear weapon under a spacecraft, and nobody ever did. But nothing about it was refuted. 60 years on, nobody has designed a better way to move a very large object to the outer planets. And the reason we do not build it is not that the physics failed us. The little machine that flew over Point Loma is still in the world, in a museum collection. About a meter of scorched hardware from a November day in 1959. The road did not run out. We closed it, and we could open it. And that is a heavier thing to carry than being wrong ever was. So here is the question, and I would rather you answered it honestly than generously. Knowing the fallout, knowing what a fleet of these would have looked like from Moscow, would you have signed it off? Tell me in the comments. This has been Sketches of Never. Somewhere in a drawer in San Diego, there are blueprints for a ship with a barber's chair in it. And everything on those pages still works.